It's Friday, November 28th, 2025. This is BitDevs Radio Hour number 2. I'm Stephen DeLorme.
I'm Alex Lewin. Happy Black Friday, Stephen.
Happy Black Friday, Alex. How was your Thanksgiving?
Spectacular. Good to see the family. Good to argue about politics.
Did you give a lot of thanks?
Yeah, I'm thankful.
How many thanks did you give?
Several.
I think that zero given and infinite thanks given is the path to enlightenment.
Yeah, I'm basically a monk in the Himalayas.
Yeah, nice. It's getting cold today.
Yeah, it's like...
Oh, wait, are we allowed to curse on this show?
I mean, I guess it's your call.
I thought it was your call. I don't know.
I think it's a family show, so we should try to keep it down, maybe.
Yeah, okay. Bad Stephen.
Yeah.
Well, we're here to talk about some more technical updates in Bitcoin and all of that kind of stuff. We're going to, at the end, go over zaps and comments we've gotten from people and all of that. So if you zapped us, stay tuned so you can hear it at the end. But otherwise, I guess we can dive into the topic at hand today.
Cool. Let's do it. Yeah, and also for the audience, if you have any questions, feel free to comment on Twitter. Send us zaps live. We'll see those on stream so we can answer your questions as you provide them.
All right, now I'm going to try and get a little screen share for those that are watching the video here. For those of you just listening later on the podcast, we'll narrate what's going on. So some of the big news this week, I've got on screen here a tweet from Instagibbs. The mempool is dead. Long live the mempool. What could he possibly mean by that? Well, he's got a link here to a Bitcoin Core PR 33629 Cluster Mempool. And if we go into there, we can see that it has been merged recently, 3 days ago. So I suspect that means it will be in the next major Bitcoin Core release. It's there on the master branch right now if you want to build it yourself and mess with it. But yeah, Cluster Mempool, that's a pretty, obviously he's trying to generate a little bit of, add a little bit of spice there by saying the mempool's dead.
Yeah, I mean, from an onlooker, like it's honestly hard to believe it's finally happening. People have been talking about Cluster Mempool for literally years, and it's actually going to be included in the next release of Bitcoin.
Yeah, I remember when we first talked about it at an Atlanta BitDevs meetup, probably in 2023. I think that's when SIPA and S-2R first wrote the proposal for it. To be actually honest, I'm not sure how to pronounce this person's screen name or if they go by another name. So if you know, Alex, please correct me.
Yeah, I think it's pronounced Daft Punk.
Daft Punk?
Yeah.
We'll just call them Daft Punk for the rest of the episode. Yeah. And actually, I think there's actually like a way that we can like pull up comments. If people comment on like YouTube and Twitter, we'll see it. So maybe someone will like shout out and tell me what an idiot I am. But yeah, so we've got the pull request right up on screen here. We also have a delving post that we can look at that's also from Daft2R about the proposal and what it means. I think we should probably, instead of like looking at this stuff line for line, just kind of approach this from the what does it do for the world? So yeah, I'm prepared to tell that story, but any comments you want to make before we dive into story time?
Yeah, maybe like first, what are we talking about? So this is Cluster Mempool. First, what's the mempool?
Perfect place to start. Yeah, I mean, if you're not familiar with the mempool, that's the memory pool. It's the basic idea. I like to think of it as just a queue of transactions waiting to get in line, waiting to get confirmed into the next block. So waiting in line is one way to think about it. They're unconfirmed transactions, right? But if we think about it as just a queue, like a line, that wouldn't be totally accurate, because in practice, it's a little bit chaotic, I think, because, my wallet makes a Bitcoin transaction, signs it, broadcasts it to the rest of the Bitcoin network. And what I hope is that it gets picked up by a node. That node then propagates it to another Bitcoin node. And, in a matter of seconds, it's propagated through the entire Bitcoin network. But, in practice, this doesn't always, work. Some, nodes might have different mempool policies than other nodes. There may be other various other reasons, why it has difficulty traversing the network. So in practice, not everybody's mempool is going to be the same as everyone else's mempool. But the idea is in a like kind of perfect, beautiful, theoretical world, every Bitcoin node has a mempool, and it's like roughly like what everybody else's mempool is. It's just this cluster of, if I want to make blocks as a miner, these are the transactions I can pull from and put into blocks.
Yep. Yeah. So everybody has a mempool. If you want to get a transaction included in a block, you dump your transaction in the mempool in hopes that the miner will eventually uh, snatch that up and put it into a block. Um, but maybe what are some of the problems, the historic problems of the mempool? Is the mempool a beautiful place that's super organized in the past, or is it?
Oh
How do you?
no, it's a dangerous place actually. I think actually some of the dangerous things might be worth getting into later, but like just to focus on like the problems at hand, like kind of like what's wrong with the old mempool. I guess you'd say it's the existing mempool because it's the one most nodes use, but as soon as everybody updates, it'll be the old mempool. So what's wrong with the old mempool? The old mempool, like we have to think about like who's going to be using the mempool, right? And like why we need to think about like transactions in the mempool. So like one like kind of user of the mempool is miners. So if I want to get a block template, then I need to know what transactions are in the mempool. And as a miner, I'm incentivized to mine the block that's going to get me the most fee revenue, right? So I want to my understanding of it is that basically when the algorithm that helps like Bitcoin Core get a block template is basically looking at a transaction and it's looking at its ancestors. So basically, like I have a transaction, does it spend an output created by another transaction that's also in the mempool? And it's looking at the fee rate of the transaction and its like ancestors. Whereas when we're talking about the other user of the mempool, which would be eviction. Eviction, scary sounding word, just kind of, it's just the technical word for it. Your mempool can't be like infinite in size, right? So like I think the default is 300 megabytes for Bitcoin Core. You want, at a certain point, your mempool is going to fill up with too many transactions and you have to start evicting transactions. Well, what transactions do we want to evict from the mempool? Well, I mean, if we have to evict transactions, I don't think we want to evict any of them. But if we have to evict transactions, we want to evict the transactions that are less likely to make it into the next block or the block after that or the block after that. And so when eviction occurs, the Bitcoin Core is basically going the other way. It's like, well, take this transaction and all of its descendants and what's the fee rate of all of this combined. And you would think, like, what would be the problem of this? Because if a miner is looking at the problem from one direction, like what has the most fees, and if the eviction algorithm is looking at it from the other direction, what has the least amount of fees, you would think that it would just be perfectly opposite and symmetrical. Like whatever the mining one says would be the opposite of what the eviction one says.
Yeah, like maybe as an illustrative analogy, like you could think of a bunch of people waiting in line to get on a ride or something, and you'd expect that, if the line gets too long, you have to kick off the people at the back of the line. And you'd expect the people at the back of the line not to overlap with the people that are about to get on the ride. But that's not the case of how Bitcoin works today, is it?
No, it's not. And transactions are more complicated than that. It turns out that you will not get the exact same results. And so it means what the problem that this introduces is if a mempool, a Bitcoin is mempool is trying, it's like trying to evict lesser fee paying transactions from its mempool, it's going to give you a different result than what the mining algorithm would give you. And so that means that we're evicting stuff from the mempool that's not aligned with the natural incentives of miners.
Yeah, like we can accidentally evict stuff that we actually want to include in the next block.
Exactly. And this makes it this is problematic. I mean, I think for one, you want your you want your mempool to reflect you want it to be an accurate reflection of good miner fee revenue. Um, you also want to be able to accurately determine fee rates. I've heard that this really complicates RBF just in terms of like trying to replace by fee. Say I have a transaction, I want to get it mined sooner, so I want to up the fee. This process really complicates it, and it might be worth digging into. Like, well, why is it that these two different algorithms aren't the polar opposite of each other? Like, why is it that one gives me one set of results and one gives me a different set of results?
Yeah, I mean, I've heard so like all of these we're talking about mempool policy rules
Hmm.
and just like what you're supposed to do to update the mempool in certain situations. So like the big one like we were talking about is the get next block or like create
Hmm.
block template RPC. So for mining, there's the natural process of clearing out the call it waste or spam transactions that are too small to ever get into blocks. So that's evicting when the mempool gets too big. And then there's also crazy rules with RBF. So I've heard all of these rules should effectively be talking about the same thing, but how it's implemented today is that I've heard it described as spaghetti code. It's spaghetti rules with overlapping rule sets. There's no unification with all of these different actions, even though that they're all related. There's just heuristics. So as soon as you try to do anything complicated with the mempool, like RBFing complicated transactions,
Hmm.
you start to have wonky behavior.
Yeah, I think there's another thing to explore here, which is when you have transactions, like if you were talking about the example of like people trying to get on a ride, and how it should be symmetrical and opposite. When we talk about Bitcoin transactions, it's far more complicated than that, because like a simple example might be like, okay, I have a Bitcoin wallet, I send a transaction that's an unconfirmed transaction, so it's just one output creates another output. But it could get more complicated. I could send you Bitcoin, broadcast that transaction, and you could try to spend that transaction before it's confirmed. So now we have a child transaction. Or maybe I want to get it to you sooner. So I want to fee bump it. So I do child pays for parent. So I broadcast, we try and broadcast another transaction that spends from that in order to get it fee bumped. But it doesn't, it gets more complicated. And this is where I think it becomes very difficult for the old mempool to kind of keep up. Is let's think about a lightning channel. I want to open a lightning channel. Well, I might be putting in multiple of my inputs, and then what I'm going to do is I'm going to put multiple inputs in, and I'm going to put that into a 2 of 2 multisig. And then like later on, I want to close that channel, and that channel has one output going to me, one output going to my channel partner. you know it starts to get complicated, and both me or my channel partner could try to spend from those. Let's think about an even bigger thing. What about a coin join? We've all heard about these various privacy tools, and a lot of times you might be talking about 100 different outputs. Well, what if participants in those coin joins try to spend those outputs before they're confirmed? Or what if you have a bunch of people withdrawing from Coinbase and it's all batched into one batch transaction? And again, people are trying to spend those outputs before they're confirmed. So you could have a transaction with like 100 different outputs, and each one of those outputs could have its own like child transaction.
Yeah, so just like the old rules, if you have big complicated transactions like this, you're just helpless. Like you have no idea what's going to happen to your massive chain transaction if there's a bunch of outputs and a bunch of people involved.
Yeah.
With these old rules.
Yeah, it's not as simple as just a bunch of people getting in line for a ride. That's why I very quickly disposed of the queue analogy at the beginning of the show.
Yeah, it's like, what if your queue is filled with people? Some of them are handcuffed to each other, and some of them there's like a weird like incestuous family relations with a really fucked up family tree. So there's some of them are somewhat related, and others are still related but less related. It gets very complicated quickly about how to kick the whole family out of line at once.
Oh, yeah, that's got to be a difficult wedding to get invited to. Um, well, why don't we dig a little bit, and we're kind of looking at some various examples here, and it's showing like transaction A and it spins to transaction B and transaction C. There's all kinds of different paths you can take here. Let me just find Yeah, this is a really crazy one right here.
There was something talking about the idea of making RBF rules incentive compatible with minors. Like this is, I think, an important concept. Yeah, here we go. The first question is to ask what incentive compatible should mean. So, um, in an ideal world, we want the policy rules set in Bitcoin Core to be aligned with miner incentives. We don't want miners to be incentivized to break policy rules. And this is something that like dictates a lot of the policy decisions and you know I think some people have like really interesting ideas for mempool policy, but because they aren't incentive compatible with miners, like if miners, if there's a situation that a rule creates where the miner is incentivized to not follow the rule, then we can't have the rule. We want miners to always to always have the most profitable route be to follow the rules. Anyway, so this is a
Yeah,
big motivation and like why this problem is very hard to solve.
yeah. Um, why don't we get a little bit into the like, well, what does Cluster Mempool do that's different? Um, so we said earlier that there's these kind of like two different algorithms. There's the one there's the one that the mining side of Bitcoin Core used. There's the one that the mempool eviction side used. Cluster Mempool is this project. My understanding of it is it's trying to kind of unify that with just one algorithm, or trying to unify that with just like one methodology, so that the eviction side and the mining side give you the same thing. And so the way that it does this is it basically kind of reconceptualizes the mempool in terms of clusters. And I think you can think of we're looking at on screen right here. It's this diagram of transaction A spending to B and C. You can think of this as being a cluster. These are a cluster of related transactions. These children here depend on this parent. Transaction D is over here. It's like a whole different thing. It's kind of like a cluster of its own. But so we stop thinking of transactions as like these individual things that we need to rank and sort, and we start thinking about these as clusters. And then there's this process called cluster linearization. And yeah, I mean, to be honest, this is the part where it gets a little bit theoretical and mathy and a little above my pay grade. But the basic idea is so like a cluster is a directed acyclic graph, right? So we're like this example we're looking at on screen here. It is acyclic, meaning that the arrows only flow in one direction. You can't find a path through this graph that gets you back to the beginning. And that makes sense because like how would like a transaction spend back to itself? Like it doesn't make sense. So you mathematically you represent like a cluster as this directed acyclic graph. And then there's a way that you can linearize that. And by linearizing it, it's like the way it's like you're basically putting them all in, you're taking all of the transactions that would go in that graph and you're putting them in an order. And so it's like parent child, parent child, parent child. Obviously you need a parent to be included before a child. You can't have a child transaction be mined before the parent transaction that it spends from is mined. And so the purpose of this linearization process is to basically take this complicated cluster graph of transactions and organize it into a line, a queue, like we talked about at the beginning, and put it in a way to where you're making sure that the parents always come before the children, and you're then able to take. You can basically, once you've organized them by that, like parent child, parent child, parent child, those become chunks. And the kind of magic that ends up happening is you can then rank all of those individual chunks according to the total amount of fee revenue as compared to virtual bytes. And from there, once you have all the chunks in order, you can then make an accurate, more accurate estimation of what should go into the next block, what shouldn't. And from there, if you do the mining side, what do I want in my block, or the mempool, what should I evict, they'll actually produce symmetrical results.
Cool. Yeah, I mean, in computer science, this is like close to some like a concept called topological sort. So like if you're sorting like items in a graph, oftentimes you care about like strict ordering. Like there's a strict ordering of the graph. So You never want a child to show up before the parent. So this is just a fancy, like the linearization process or the normalization process where you flatten everything. That's like my understanding is it's just a fancy topological sort.
I see.
You get these nice fancy organized clusters that will always be in the right order for anybody using the mempool. Yeah, both the miners and the evictors.
And that's what we want. We want this to all be, incentive compatible. And I did come up with some questions while I'm not sure if this might just be a question we need to answer on another day, but maybe you can help me with this. I was kind of curious, why was it necessary to just redo everything as clusters? Because it seems to me like the lowest hanging fruit would have just been like, okay, we have one way of sorting transactions for mining and getting block templates. We have another way of doing this for, we have another way of doing this for eviction. Why not just pick one of them? And why not just for example, do the mining one and just be like, okay, we're sorting everything in accordance with what's going to go into the next block, and anything that's beyond the size of my mempool we're going to evict. I wonder why it.
Yeah, I think the intuition for this is that if you treat each transaction as separate, then you will miss information when taking a greedy strategy.
Mm-hmm.
If you take a greedy strategy on ordering transactions without grouping them together when there are relations between them,
Mm-hmm.
then you will just flat out miss information. And the base case of this is it's like an analogy of tickets to buy to like a train ticket. So if you have a bunch of people with train tickets and there is a parent that has a very cheap ticket, but they're holding the hands of their child with a very expensive ticket, it doesn't make sense to evaluate just the parent without the child.
Hmm.
So if you have a parent with a $1 ticket, but a child with a $100 ticket, you might accidentally reject the parent before even realizing that the parent-child combo together is worth over $100. So the idea of clustering it together, in the past, we had a bunch of ad hoc ways to try to avoid this mistake, but there are different ad hoc ways. So the clusterization process, or the cluster mempool, the whole design is you first draw the clusters and then you do an algorithm on the clusters rather than the individual transactions.
I see.
So does that make sense?
I think so. Yeah.
Yeah.
I think another thing that I found interesting going through this was we're actually, I'm going to see if I can find an example here. CPFP. I'm searching through this page. Yeah. So the CPFP carve out rule can no longer be supported. Well, that's a mouthful. So what does that mean?
So first, CPFP is child pays for parents. So this is the exact situation that I'm talking about, is where a child transaction has a higher fee than the parents, or the child fee, or that the child transaction effectively pays for the parent.
Yeah.
This is a way of fee bumping.
Well, so the carve out rule. So this is like a whole other rabbit hole here with the carve out rule. So I was familiar with child pays for parent. I was wrapping my head around the carve out rule as I was reading this, and it's all very intertwined with pay to anchor and truck and V3 and all this kind of stuff. So let me. I thought this was an interesting, because I spend a lot of time focusing more on Lightning stuff. So this is very, very relevant for anyone who develops for Lightning. So have you heard of channel pinning attacks?
I have.
So a channel pinning attack, for anyone who hasn't heard, is this idea that, let's say Alex and I have a Lightning channel together, and we're going to close the Lightning channel, but what Alex, if he's malicious, he can do is he can basically do a child pays for parent transaction, and he can create another transaction that spends from our Lightning channel closed transaction, and then create a transaction that spends from that that spends from that one, and then from that one, and then from that one, until he hits 25 transactions. And I actually realized my Mac is about to die. So okay, we're back.
Welcome back, everybody.
Yeah, we were just kind of before we had the AV issues, talking about channel penning attacks. And I was going over this idea that you can't have a node just accept endless amounts of child transactions, because if you do, it's a denial of service vector. It's like, if I can, why can't I then create a million child transactions that are totally valid by consensus and broadcast them to nodes and expect the nodes are going to process these? And while they might be consensus valid, these are the kinds of situations that, one, a node has to spend its time validating the signatures on these transactions, but it also has to consider this long chain of transactions when it's trying to, determine whether to evict stuff from the mempool or whether to include stuff in a block template or not. So there are a limit on the number of child pays for parent transactions you can have, and I think that's 25. However, this created a problem with Lightning called channel pinning attacks. It's like, if you and me have a Lightning channel together, you turn evil one day, you decide that when we're closing the Lightning channel, you are going to spend from your portion of the channel and spend and spend and spend until you've used up all 25 child slots. And that means and if you do that at a low enough fee rate, effectively, our channel close is stuck in limbo in the mempool.
Yeah, like I can't make the extra transaction on top of that to correct it. Like your
Yes.
error is stuck, it's pinned because you've hit the limit, and there's a rule saying that you can't go beyond the limit.
And so the carve out was this thing to prevent pinning attacks. And it says, well, okay, if my evil channel partner filled it up with 25 25 children transactions, there's still a carve out. There's still room for me to make a child transaction broadcasting from my output in the channel close. And that little carve out would prevent the channel pinning. However, under the cluster mempool design, there is not a child pays for parent carve out. It's not, again, this gets into the territory where the whole linearization stuff is a little too much for my brain, but I just don't have the formal training to really understand that fully. But it's just not really feasible to do the CPFP carve out in this mempool design.
Yeah, I mean, I think it's like, yes, so the CPFP carve out rule cannot exist. I think this is kind of a good thing. It's like the CPFP carve out rule, in my opinion, is one of the grossest policy features of Bitcoin. Like it feels very hacky to have this special rule of how to have transactions or how to process or allow certain transactions just for this one tiny, very specific case for Lightning. So the fact that we no longer have the CPFP carve out is good. Unfortunately, until we have, I think it's like transaction v3 or like
it's here.
There's something we're waiting on, and we have another stopgap solution until then called truck transactions, which is Well,
so I was actually hoping to get into that. I'm actually really excited that I feel like I can. I feel like I've Grok pay to anchor and truck transactions right now.
Okay, tell us.
Yeah. So, and I'll say this is an achievement for me because I've been to like multiple BitDevs meetups, where like really smart people have tried to educate me about pay to anchor. And I just like had a real difficult time understanding it the first time. And then when they started using the word truck, that also started confusing me. So I've been having a rough time. So, but I finally feel like I wrapped my head around it.
Yeah, congratulations.
Okay. Well, it just means, you just got to keep going to BitDevs meetups and asking the dumb questions, so to speak, even when you don't understand them. So
yeah, this is hard even for gods like Stephen.
So where should we start? So it's like, okay, so we have this idea, pay to anchor, right? It's kind of weird because it's basically this transaction that anyone can spend. And like, if we go to mempool.space, I want to see if I can just pull one of these things up here. I think it's like BC1P fees is the address. Yes. Yeah, I'm pretty sure this is a pay to anchor one here.
Wow.
So it actually has the word like fees like kind of baked into the address. And pay to anchor is this uh, really strange like output type, as opposed to pay to SegWit, pay to Taproot, all these kinds of stuff. So pay to anchor is spendable by anyone. It's like this really tiny, it takes up less space on chain because you don't have to provide like a signature, right? To prove that you can, you don't have to provide a signature to prove that you can spend it. It's spendable by anyone. It sounds a little scary though, right?
Yeah. And maybe also, this has been in Bitcoin for a while. So this is using something called any or sig hash anyone can spend. So like these have been around, like we've used them in
I think it's been around for about a year.
well, they've been around since Lightning, like anchor channels. So like anchor outputs, like the 330 step anchor output, which is
Yeah.
used for CPFP, are anyone can spend addresses
Yes.
after a certain time so that people can clean them up and sweep them.
Yeah. So what was confusing to me was that there's a couple things. What was confusing to me is like why you would want this output that anyone can spend. And so the kind of unlock for me was remembering that, okay, a Lightning channel, when you close it, it's going to have multiple outputs. There's going to be one that goes to me. There's going to be another output that goes to my channel partner for their side of the channel. And then the idea is that ordinarily the way we would have done it before is we would have, carved out a little bit for fees from either side of our channel. In this case, we're not going to do that. We're just going to make this very, very tiny, anchor output. It's going to be a negligible amount of Bitcoin. And what that then unlocks is the ability to do these basically child pays for parent fee bumps, where I can spend from that anchor output but use another output to spend more Bitcoin, and I can use that to provide a fee to the miner. So this makes it so that we don't need to know the fee at the time of channel close. And the idea is that like, well, what if someone tries to spend my pay to anchor output? Well, it's like they end up benefiting you if they do spend it because they're fee bumping your transaction for you, which is pretty clever. So that was like one unlock for me, was understanding that. The next kind of one was like kind of understanding truck topologically restricted until confirmation. And so like in this context, topology like refers to like the topology of this like kind of graph you can imagine of different transactions spending from each other. Child transactions, parent transactions, all that. You'll hear the word topology come up a lot in the like cluster mempool design. So the topologically restricted until confirmation like has this kind of rule that basically is like, you can't, it basically just restricts it so that you can't do these descendant trees of child transactions now. And V3 transactions are how we like truck as a way of thinking about it is just like more a methodology. V3 is like the implementation of it. That's the way I understand it, at least. V3 Bitcoin transactions are like the implementation of truck. And so if you're using a Bitcoin node that supports like V3 transactions, then what that means is I can broadcast a pay to anchor output. I can broadcast a transaction that has a pay to anchor output. And there's like this rule that pay to anchor, you're only supposed to relay transactions where the pay to anchor spends to another V3 transaction. You can't make a pay to anchor output pay to a V2 transaction. Like it's consensus valid, but it's not like mempool policy valid. So if you're a node that supports V3, you see a transaction that tries to take a pay to anchor output and spend it to a V2 transaction, you don't relay it. If you see a pay to anchor output that's spending to a V3 transaction, you do relay it. But these V3 transactions are topologically restricted until confirmation, and you can't do these long descendant trees from that. And so that's how this newer in the cluster mempool design, that's supposed to be the solution, like the alternative to the CPFD carve out. That's my way of it. That's my understanding.
Interesting. Yeah. Still, the idea of truck transaction. So like, yeah, we were saying I'm learning. I didn't realize that was like all the case. Like I thought truck transactions were like another um stopgap rule about saying that we're only going to allow transactions of a certain like flavor or shape for the certain purpose until something else comes.
If there is something else, I'm not sure. You might need to check the roadmap for that. But
I can't remember. But yeah, truck was like the idea of truck of yeah having these topologically restricted transactions, and having special rules for them is effectively just like a replacement for CPU or for the carve out rule. Um,
what is going on here? Yeah, just talking about cluster mempool. Um, got a comment from the audience, Rithvik. Yeah, well, I don't know. We'll have to do our homework on that one a little bit more. Then I'm not sure if there's something else that's like coming. If somebody knows, let us know. Zap and boost us on Fountain.fm. Let us know.
yeah, the moral of the story is, we're in pursuit of simplifying all of the rules and aligning everything. We still have a bit of complexity. That's kind of my takeaway from this.
Yeah.
Is like it's still not like it's definitely directional. It's in the right direction. We can now be confident to support more complicated transactions. Yet it's still pretty complex how it works, but it should be unified. And at the very least, we can have confidence that we're building towards something that is um, better than what we have today.
Um, and that's kind of a good segue into this post from Bastion from Async. Sorry, Grok is like getting in the way. 1 year later, we now have two compatible implementations supporting zero fee channels. That's Eclair and LDK, and the spec is final.
Let's get hyped.
And so he put out a huge thanks to Gloria and InstaGibbs, who made it possible by working on mempool policy. And so, yes, it is now. What he's saying here is that the bolt spec is final, and I guess it would need to be. I guess it's capable of being ratified now because there's interoperability between two implementations, but it does appear to be an open um, PR. But it's just kind of goes to show like how all of these complicated pieces fit together. It's like we have paid anchor outputs now. We have V3 truck transactions, we have ephemeral dust, and now we have cluster mempool, and we can do things like zero fee lightning channel closes.
Yeah, I mean, it makes me think like when people talk about like Bitcoin being restrictive for protocol design, like when people complain about Bitcoin being too restrictive, they're usually talking about covenants and they're usually talking about opcodes. But Lightning has been pushing against the wall of how the mempool works for years. Like we have Lightning has been hampered and it's been kneecapped by just how the mempool would evict transactions of certain kinds. So it was unsafe to use certain pre-signed transaction architectures. So we're if people are wondering what Bitcoin developers work on other than covenants, this is a big example. The mempool policy, while it was complex, prohibited layer twos like Lightning to be able to design protocols as they wanted to. So this is huge for Lightning.
You're right. Well, should we just why don't we dip into some fun stuff now?
Yeah.
Or
Okay. So that's enough cluster mempool. Any final thoughts about cluster mempool?
well, it's just cool to see something go from proposal all the way through discussion and implementation, and then about to be launched. So it's exciting to see.
Yeah, I mean, one other thing I'm excited about is like some of my friends that are maybe more academically minded really respect cluster mempool from like an academic's perspective. Like apparently, cluster mempool is like provably optimal in every one of these situations. Like the algorithm that we've settled on that we're still not. It's not like we're merging it. It's going to be in use, but perhaps all the bells and whistles aren't finished. But the core structure of the algorithm will never have to be changed again for all of eternity. It's like provably the best thing possible. which I think is very cool that we can have software that's like provably correct.
That's
Yeah.
provably correct for all of eternity. I love it.
Yeah.
All right, what else we got? I got a grab bag of different news items I've pulled up. I thought this caught my eye. A tweet from Core Lightning said release candidate one for Core Lightning version 25.12 is live, and they list a couple different features. But one that caught my eye was experimental LSPS2 support.
Ooh.
That is the LSP spec version 2.
The
Uh,
word spec is in LSP, the LSP spec acronym.
I probably just misspoke there. Lightning Service Provider Spec 2.
Okay, so S. The second S in LSPS2 is the word spec. Okay, no,
Yes,
sorry.
that's correct.
Cool. Very exciting. So what is new about LSPS2?
I mean, so there was a project a couple years ago called balls.dev, and it was, funny, balls.dev. I mean, the website may still be up, but it was Bitcoin and Lightning layer spec. I think some of the people from the BitKit project were kind of kicking it off, but it was like an open source thing. They were trying to build a Lightning service provider spec. The idea being that like, um, right now you can go to like websites and be like, I want to buy a channel. I want, I'm going to give you my node pub key and I'm going to pay an invoice and ask you to open a channel to me. But that's kind of clunky, right? If you have all these different websites you have to go to. So like, wouldn't it be great if there's just like interoperable spec so that there's just kind of like an open, like interoperable way to find different LSPs and ask them for channels?
Yeah, this would create like a marketplace for liquidity, not just a bunch of individual service providers.
Exactly. And I don't know exactly what happened there. There was some work done for specs in that repo. And then eventually it moved over to like the Blips repo, the Bitcoin Lightning Improvement Proposal, whatever. So the things that like sit alongside the Bolt. So there's now a new version of the LSP spec that's there. And so that's really cool because I think uh, we've certainly seen some major LSPs go down over the past couple of years, and I think it would be really, really good for there to be like an interoperable way to just get liquidity when you need it. And so, I don't have a lot to deep dive on there. I just think it's just like directionally cool.
Sweet. Yeah, I remember when people were first hyping up the LSP spec. Um, is there anything noteworthy that's new about LSPS2 over LSPS1?
No, I would need to deep dive into those blips, which I have not done.
Cool.
So here is an interesting story. This was the subject of plenty of laughs in various Slack, Telegram, and other chat venues this week. JP Morgan Chase closes Strike CEO Jack Muller's accounts, spurring crypto debanking concerns.
What? Bitcoiners getting debanked?
uh, Actually, I don't have it on screen right here, but there was a funny tweet from Jack Muller's where he got it framed, like the rejection letter.
Oh my god. Yeah, that's crazy.
Yeah.
What a renegade.
Yeah, it was so in August. I'm just reading out verbatim from this Block article here. In August, President Trump signed an executive order that penalizes firms that debank crypto-related businesses. Quote: "The Trump administration has already ended Operation Choke Point 2.0 once and for all by working to end regulatory efforts that deny banking services the digital assets industry." Trump's working group on digital assets markets said back in July. So it's like nobody knows if is it actually like Operation Choke Point still live, or is it for something else?
Yeah, I don't know. I mean, like, is there anything specific that prompted his debanking, or was it a blindside?
I mean, I don't think anybody knows, but what keeps coming up is this video where he kind of he he says somebody is asking him in an interview like, what do you think about like what Jamie Dimon said about Bitcoin? And he's like, I don't care what Jeffrey Epstein's banker said about Bitcoin.
Okay, so the subtext is that this is a retaliatory measure by J.P. Morgan for Jack Mallers, yeah, calling J.P. Morgan a shelter for pedophiles.
Yeah. Oh, we actually got a comment from the chat here from the Tesh BTC. LSPS2 is just in time channels.
Oh, cool.
Sweet. Thanks for that context, Nitesh. Um,
So what do you think do you think that's actually the case? Do you think that this was a retaliatory measure against Jack Mallers for speaking out against the tyranny of JP Morgan?
I don't know. Uh, I have no idea. I mean, it's so hard to know with these things.
Yeah.
I mean, it does seem like if some rando gets a letter in the mail saying we're closing down your bank account, it could just be like, oh, this you went to Coinbase and bought a little bit of Bitcoin or something like that, and they see it and flag you. It's like, we have a general policy that we close anybody's accounts that has to do with exchange, like a crypto exchange, right? So like there's like if it's just a random person, it seems kind of like, okay, you just got kind of caught in the system. Um, when it's like the CEO and kind of like a more public figure, it feels a little bit weirder. Like you got to know that if you're going to close the accounts of someone who's like a public figure who goes on NBC all the time, like you got to think that's going to hit the news.
Yeah. Well, I don't know. Yeah. Okay. Yeah. So if JP Morgan, yeah, probably could expect that this would blow up on social media, given also that like Bitcoiners are very excitable about talking about debanking as well.
Yeah.
So yeah, sure they saw that coming and made a calculated decision to nail him for either, his insults or otherwise.
Yeah. So, oh well, at least he's got Bitcoin.
Yeah. Well, also he's building something that's like his company is positioned to replace the need to have a bank or like either be the bank for their users or to just be the financial services provider to obviate the need for a bank. So he'll be okay.
Now, if Strike got debanked, that would be like, everything's on fire. But it's just Jack Mullers.
Yeah.
So next little fun tidbit. So Signal has a backup feature now. I figured out the private messaging app. So they have a backup feature. Apparently, they launched this back in September 8th. You can actually do it on iOS now.
Cool.
Yeah, that was always been an annoyance to me. Have you ever had to try to migrate Signal from an old phone to a new phone?
Yeah. No, that's interesting. So you could always back up your account, but not your message history, it seems like.
Yes, that's correct.
Cool. So now with Signal, you can, I guess, you can actually back up the message history itself. Um, cool.
Yeah, and I feel like there are some ways to do it. Like I think that it's like Android to Android, I think worked a little bit better, but it was still clunky. And it's just because of their whole like new no user foot guns philosophy. They would it would be uh you'd run the risk of like not getting all your message history because they weren't going to do anything that would accidentally, leak your message history or something like that. But now there's an opt-in if you really, really absolutely need those, messages backed up, you can opt in to do these secure backups. So that's kind of neat.
Yeah, this is cool. This is something we talk about at my company. Like I also work on a chat app that really cares about user privacy and doesn't want to leak anything to the server. And um, yeah, it's really hard to figure out how to back up messages that are end-to-end encrypted when the server doesn't even know that these messages really exist.
Yeah.
Like you have to do very sophisticated things. So right now, yeah. So this is also the behavior of Fetty.
I mean, I've talked about this before at the Jordan Bravo on Cyber Computing show, and like his philosophy is just like disappearing messages all the time. I think.
Yeah, I mean that's enough for some people. But some people want to be able to look through and
Uh,
reference the conversations they had.
yeah, I mean it's like I can see both sides of it, but it's like we do leave a big trail, so we leave a huge digital footprint and trail everywhere we go. So it's not the end of the world if you can't figure out backup. Um, it's like an experience people expect, I guess, nowadays with, iMessage and you get a new iPhone and all your iMessage content is automatically there and all the privacy focused apps, don't always have that experience. So
Yep. Yeah, I mean Telegram took a different path. Like Telegram is not private by default, but then they have a privacy mode. They have secret chats if you care about privacy. And I bet I don't know if those secret chats actually get backed up. Um, But yeah, it's always a balance between being super private and having phenomenal,
Yeah.
never think about it UX.
Yeah.
So it's cool that Signal finally found a way to do this.
Yeah, exactly. All right. Well, I saw the kind of topics, the topics that I got. Where should we? I guess we can read our zaps and all of that. But do you have anything else you want to chat about while we're here on the air?
Maybe one thing I was thinking about is what are you thankful for? It's Thanksgiving. It's for Bitcoiners. There's a lot to be thankful for the world like Bitcoin existing. Stephen, do you have anything you're thankful for in the world, in Bitcoin or otherwise?
Oh, just, thankful for my girlfriend, thankful for the wonderful community we have here in Atlanta, and everybody who shows up every week to learn about Bitcoin and freedom tech together, and that's the important stuff in life.
I'm
Everybody.
thankful. Yeah, that's beautiful. I'm thankful for you, Stephen. I'm thankful for the community you've built here. Thankful for Bitcoin as an industry of having so many motivated, talented people working together on something beautiful and to solve real problems. So, yeah, no, I'm super excited for the next year.
Well, let's go ahead and take a look at our zaps and wrap it up here. I'm going to share the screen again here. What are we doing? That looks like the right screen. So we're on we the Monday after we do the stream, we post this to Fountain, and you can go to fountain.fm and you can find an episode, and if you want to leave us a tip in Bitcoin, you can hit the support button right there and I'll do a lightning payment. Did we get any zaps on the last episode, on the first episode?
We didn't get many, but we got one very noteworthy zap. So, massive shout out to Michael Saylor himself for zapping our first episode of the podcast. Michael Saylor, it means a lot to us that you want to send us money and support the work we're doing. So, yeah, thank you so much. It means a lot. To the audience, if you want to be as cool as Michael Saylor and get your zap read aloud on the show, you can zap us. Yeah, at the end of every show, I'll go through the zaps and acknowledge everybody who is supporting us. So thank you, Michael Saylor, and hopefully there'll be more to come next week.
Yeah, I mean, it's huge that somebody like Michael Saylor wants to support Bitcoin open source software and having these sorts of, open discussions about Bitcoin technical development. So we really appreciate it, bro.
Yeah, I love it.
All right. Well, we will see you next time.
Yeah. Happy Thanksgiving. Happy Black Friday. Thanks for joining.